All right. So this particular presentation was by invitation, and from NOARS and Elaine specifically, and because there was interest in some of the discussion at one of the meetings about some of the newer products of COMPACTenna. So I'm delighted to present that today, and I'm glad to see everybody here. Thank you for coming. We quite a bit more than it would have been last week. So this is a blessing not in disguise. So now there are really three new models, but it was also requested that I speak about an existing model, the 2M220 440, the 2-meter tri-band, in conjunction with it for a just to bring it into perspective. So I did that as well, and it's all on the PowerPoint that I'll bring up in just a moment. Okay, so I'll go ahead and bring that up. All right, there we go. And Carl, do you see that in full screen?
Yes, yes.
Well, this worked out very, very well then. I'm checking one thing and then we'll proceed with this. All right, very good. And then I'm going to bring this pin up there. Okay, that's good. All right, wonder if I can reduce this in size a little bit. Oh, I see. All right, that's about as small as I can bring it. All right, so what I'm going to do here is talk about a little bit about the background, but not too much. We're going to jump right into those three new models, and in conjunction with the existing model. But just as a brief overview, and I will say that on my website, COMPACTenna.com, on the homepage, there is, for example, some videos, and one of them near the top discusses in more detail the science and technology of this. So again, I'm just going to brush over that, but if you want a further explanation or review this in the future, Carl is apparently going to work on bringing it up to YouTube. You can review the slides here, but again, there's another video that discusses it in more detail. So this is all about small, high-performance antennas, as most of you know already. Typically an oxymoron, but this is definitely a different design, a patented design. All right, let's see how this works here. Okay, all right, and there we go. Now we have control. All right, so COMPACTenna, compact antennas, and for what? Small, powerful antennas for ham radio, CB, scanner, LMR, which is land mobile radio, GMRS, those are together, and shortwave. All right, and the three new models include a variety of these categories. The basic outline of this presentation, parts, science and technology. Again, I'm just going to brush over that, but there are some slides there some of you may not be familiar with that you might enjoy, appreciate. And then the second part, the models, VHF, UHF, the vehicle, the base station application. This is one of the new products, the compact counterpoise for stealth operation of base station VHF, UHF antennas. Really cool. Nothing brilliant, really, but clever. Yeah, I think you'll agree. So we have VHF, UHF vehicle and base station, and then we have HF. Although HF is not part of the three new models, there is a little thing at the end because there's a couple of new really exciting YouTube videos that just came out that included the 20-meter antenna. So in terms of the science and technology, it boils down to two things. The new design being a small antenna, to be a high-performing one, that was the intent, and to do so in an entirely different way, because using standard technology just is insufficient. So this incorporates what I call the magnetic field resonator. It's essentially an extended flat monofiller Tesla-like coil plus additional geometric structures. So you'll see a little bit about that. And again, there's a video that on my website that talks about it some more. And in the long run, what that does is incorporate all of the matching components within the antenna structure itself. So rather than external or internal to the antenna having lossy matching systems, this is part of the radiating signal generating field of the antenna itself, and also in the method that it does that with phase delay, with the diverse electromagnetic fields, it results in flutter reduction. So it does two things, and the matching within the antenna itself, non-lossy, it virtually eliminate the losses of standard matching systems of antennas, and secondly, flutter reduction because of the diverse electromagnetic fields. That mitigates weak signals in the obstructed world we live in. Most all our communication is in the obstructed world for both analog and digital. All right, so again, I'm gonna brush over this. If that was the intent, was to focus on the new models, and I appreciate that. But there are really three parts, and I've already alluded to it on the prior slide. Three parts: the extended flat monofiller spiral Tesla-like coils. All of the matching is efficiently done within the geometry, as opposed to internal or external lossy components of other designs. Right? And we can. I'm really open to questions at the end or at any time if you'd like to interrupt. But and we can always go back and talk about any questions. This is done. Whoops, I'm sorry about that. In the process of accomplishing this unique design, patented. This patent number here, the magnetic field resonator, it's a built-in resonating matching system, and as I pointed out, it not only reducing the loss of standard matching system, but it's an effectual component of the electromagnetic field production. That's huge. That's absolutely huge to be able to do both things at the same time, right? So even lossy external systems, whether at the base of the antenna or intrinsic, but not part of the radiating field of the antenna, yeah, there may be some electromagnetic field production of those matching systems, coils, caps, et cetera, traps, gaps, but unfortunately, they are not an effectual. There's negative cancellation or literally grounding out, resistance loss of whatever field they're producing. This is entirely different. This all came in the visionary thinking while awakening all at once. If you can do all of this at the same time, then you actually can absolutely maximize the performance you get in a small antenna differently than ever before. Absolutely maximize it and give you surprising, even amazing results. So the resulting diverse electromagnetic fields, I pointed out, right. So think in terms of elliptical polarization. As you get reflections throughout the world as you're driving along, or even stationary, and it's a dynamic world. The trees are moving, people are moving, doors are moving, vehicles are moving. You get all kinds of multipath, and it changes the field. It can flip-flop into polarization, these kind of things. Again, I'm brushing over it, but in having the phase delay in the diverse electromagnetic fields that are produced by the magnetic field resonator, you wind up having flutter reduction. It's really good in the analog, which can be irritating, if not even dangerous. Both for the ham as well as the LMR community, but extremely effective in digital communication, not just for the audio, but for the for all kinds of digital communication to maintain connectivity and increase throughput. Okay, all right. So let's brush over this. There are different terms that I've coined because the standard literature just doesn't have some of those terms. So bear with me. And I'm fortunate to be able to give this presentation at this time because it's been out there now for some years, and even the naysayers, you know, are coming on and saying, wow, I actually bought one and I was very mistaken. A recent eham.net review said that. So this opens up people's minds a little bit more to what is and what is not snake oil, and this is not. See, in the past, we focused very much on gain, right? And then some of us a little more focused, sophisticated, focused on efficiency, antenna design engineers. There's so much more to the effectiveness of an antenna, but particularly in the obstructed world. So, you know, antenna efficiency is the ratio of the power radiated by the antenna to the power supplied to the antenna. In other words, you put, you know, 50 watts to the antenna, how much of it comes out, you know, into the airways? Perfect is 100%. You actually don't find that often. Certain dish antennas, a perfect dipole, these kind of things. Many effective antennas are 50 to 60%. There are actually nowadays many antennas that are way down around 15 to 20%, even less than 5%. Shark fin antennas on vehicles, some of which I've developed working for Amphenol, and AM/FM antennas, cell phone antennas, these kind of things. So there's efficiency. Yeah, that is important. But then there's also SWR. We're so familiar with that, impedance matching, because if the power goes forward, but some of it comes back, well, then it's not even there at the antenna to be radiated. So I'm brushing down this. Then there's radiation resistance relative to the feed impedance, the matching circuit, energy radiated by the matching circuit, effective or not at all, or virtually not at all. So you see, we continue to look further into what you need to do in order to do something different. You need to address all of these issues, all of these matters, as it were. If the radiation resistance is very different than 50 ohms, well, then you have to have the matching circuit and effectiveness of that. The element resistance loss itself, you know, it's actually significant. You look at a company like Pulse Larsen, it was Larsen and Pulse Larsen, you know, they developed the cool rod, you know, even though it was only a little bit decreased, it was stainless steel whip, you know, flexible stainless with, you know, we all use a quarter wave whips on vehicles, you know, they did a triple coating in order to at least, you know, a certain percentage decrease the amount of heat loss. Well, one of the things that can be used are wider elements to decrease a resistance loss. And that is done here in the monofiller wide Tesla-like coil. There's dielectric and substrate resistance and loss. I am actually brushing over this, all of this. For example, when you have patch antennas, or even non-patch antennas, there's the dielectric, and there can be resistance loss there. Resistance is not good. You know, that what's a pure resistor antenna? That's a dummy load. So, and then the substrate resistance, other non-radiating components of the antenna itself. Matching system resistive heat loss, that occurs as well. You know, coils, small diameter wire, you know, heat loss. Again, brushing over it. And then there's this, the field effectiveness of the matching system. You know, they all produce some signal generation. This one produces a lot, the matching system. There's loss. There's loss to ground. There's negative interference. You know, there's cancellation of the signal that's actually produced by the primary radiating element. Oh, that's right there, of the matching circuit and system. So getting the matching system within the antenna itself and making it of low loss, yes, that's important. And then producing an effective signal from it, electromagnetic field is important. But then it needs to be produced in conjunction with the primary component, so there isn't cancellation. All of this is important. It's very specific. The gain. Oh, we finally get to the gain, right? The pattern. Most of us look at the elevation coordinate pattern, for example. Azimuth is basically, when we're talking about omnidirectional antennas, it's all the way around in a circle, 360 degrees. The elevation coordinate pattern is important. The tighter the elevation coordinate pattern, the higher the gain. And that's good. Sometimes, not all the time. For example, what is the effectiveness relative to the environment and the topography? If you're down in a valley, a lot of us know a quarter wave antenna on your car is actually more effective than a 5/8 wave or even a collinear super high gain antenna, because those essentially compress the elevation coordinate pattern. They compress the pattern and basically shoot the signal right into the side of the hill. Okay. So all of these things, that's just one basic area where it opens up the mind to realizing that gain is not everything. All right. And then field diversity in the RF obstructed world. I talked about that before in flutter reduction. All right. Now, brush over this. This is standard kind of technology that you're familiar with: shunt inductance, shunt capacitance. Here's everything, including the kitchen sink, but it's very real. This is from the ARRL antenna book. It shows that it's actually more complex than we realize. A whip. We've got an LC circuit that continues on its way up here. Inductance, capacitance, inductance, capacitance, inductance, capacitance, all the way. Looks very familiar, doesn't it? It looks a lot like the the feed transmission line kind of circuit. Indeed, absolutely. At the end of the day, what is an antenna? But it's a transmission line that then splits in one way or another, and then a lot of other fancy things. So, all right. Unfortunately, this kind of a thing does a lot of things potentially that are adverse, in addition to what we talked about on the prior few slides. Decreased bandwidth, for example. Oh, markedly reduced bandwidth. Decreased gain. Matching circuit inefficiencies. We talked about that. So you know, I did mention using a wide elements, sheets, for the bandwidth. That's important. In addition to everything else already discussed. Gain achieved by reducing loss and producing effectual gain in the obstructed world. So this is perhaps the last slide in the science, yes, or in the, you know, the technical part of it as such. This is essentially what it is, but there are additional geometric components. Producing the diverse electromagnetic fields out of phase in order to create the diversity, the elliptical polarization, etc. Creating this end result. When we look at the standard kind of antennas, and by the way, here's a coil. We begin to realize in most recent literature that the things are a lot more complex than we might have thought at one time. Look at everything that's going on in here. So when you have a standard helical kind of coil, which is not used at all in COMPACtenna, but in almost everything else, you have inductance from the coil. Absolutely, we know that. But you also have intertwined capacitance between the coil elements. Everything still good, Carl? I heard something beep in the background.
We're okay. That's somebody just checked in, probably.
Oh, excellent. Oh, welcome. All right. And but we have other things. We have capacitance to ground. So at the end of the day, we have the kind of matching circuit that we saw in the prior slide. And here, COMPACtenna is entirely different. There is much greater inductance per length with this kind of a Tesla-like spiral coil than you get in a helical kind of coil, no matter how you do it. You also have much greater intertwined capacitance than you have there. And the beautiful thing is that they're in parallel. This is a great assistance to the matching system. And in creating a matching system that's broadband, even though you have an extremely short antenna. And at the same time, then it produces the out of phase diverse electromagnetic field. Kind of cool, especially when you put it into real life. I want to say something real quick about the near field and the far field. I'll be talking more about the actual quantum physics of that next year, and a model of quantum physics that relates to everything, but also to the COMPACtenna, as well as other things that more recently been inventing, and within and outside the antenna world as such. We're not exactly like an antenna anyway. And the kind of combining, by the way, the aspects of Einstein and Niels Bohr. I hesitate for a moment because I don't want to expound too much on that yet. But the near field, you see, when you have other shorter antennas, like very short monopole antennas, you substantially reduce the electric field, but you very substantially reduce the magnetic field in your component. In the very small loop, you have, even though it's considered very inefficient, we talked about efficiency before, it has a relative substantially high magnetic field, but a very low electric field. Right? Well, the whole point that I'm trying to say here is this. And better understood from the model that I'll be describing in 2022, the near field, which is actually a conglomerate of near and far field components, but the electric and magnetic near field expression can summate, does summate. In the far electromagnetic field. Okay, so what does that mean? That means that if you have a short antenna, not like a magnetic loop that's essentially all magnetic in the near field, and essentially I said, and a very short monopole, etc. That is essentially, even though it's really reduced electric field, it's essentially all electric field. That's it. The COMPACtenna is totally different, as you can tell at this point. It has a lesser electric field than a full-size antenna, but it has a substantial still electric and a substantial magnetic near field system components that then add up and summate to an even stronger far field electromagnetic field than you would suspect. That's that. That's enough for now. So this is just a linear description of how it does it. All right, so if you have a high gain antenna, it's in the red here. You will have peaks, line of sight peaks that are a little higher than the COMPACtenna. So, you know, for example, if you're looking at a 2-meter antenna, you're looking at a 3-foot or a 5-foot antenna, you know, 5/8 wave, collinear, that kind of thing. Yeah, absolutely, when you're line of sight. But when you go non-line of sight, the problem is those antennas can drop down dramatically. One, due to the high gain with the compressed elevation coordinate pattern, so it's shooting signal into the sides, but also because there's no diversity at all in those antennas. So the diversity is what takes the minimized signals, the very low signals that you would normally have, and it mitigates them. So you look at that, and overall, imagine that you're sitting still and things are moving all around you, or you're driving along and you get down into the valley, or you know, you get behind that building, And at least if you're able to maintain the communication, what a world of a difference that can be. Okay. Does it work? Well, yes. People like Bob Grove, very well respected for decades in the spectrum monitor, said the prediction of signal flutter reduction was true as well. When annoying flutter interrupted reception of weak signals on the whip, reception was much smoother with the COMPACtenna. So if you're always line of sight and both antennas are up on a 300-foot tower, okay, gain. Although not entirely. A lot of times you'll have two smaller dishes because then you get diversity because of the atmospheric disturbances. But otherwise, there's a lot to be said. The problem is that when you reduce an antenna size, even if you get diversity, you can reduce gain too much. So COMPACtenna came along. This is an HF. Okay, that last slide was VHF. This is an HF. This was done by a major defense contractor, and they were surprised, although they knew a little bit about the technology, but called me up and said, how is this? I can't disclose what they planned on using this for, but this is in actually 20 meters. So they have full-size monopole, 17 foot tall, versus the COMPACtenna, 20 inches, by the way. I'll show you that a little later at the very end. So you see what happens. The peak signals are higher on the full size, 14 dB, 7.5, 22 versus 13. But look what happens when the signals get down to 1.5 dB on the full size. It's 3 dB. You can see it actually on the spectrum monitor. Here you have 7. Here you have 8. 9s are equal. Here's 8. That's up to 10. Look at these. When you're really getting down in the noise, here. Look what you got there. You do go from unusable often to usable signal. And this is not because of vehicles moving around and whatnot, or tree leaves. This is because of ionization, or the ionosphere and its constant dynamic changes in polarization and conditions. So the same thing actually applies. Now, sometimes you just have to have the gain. If conditions are poor, a 3-element or a 6-element monster, gain antenna, beam antenna up on a tower. Oh, absolutely. That's when even your greatest signals are down around here. Well, then your minimum signals just can't get above that. Okay. But when you have low, moderate kind of conditions to moderate conditions, it could be very useful, this technology. Now we get into the meat of it. Let me check the time. Okay. All right. So here we get into the meat of the various models, and we're going to focus on a few today. But we have the VHF, UHF models. We have the base station adapter. I talked about the compact counterpoise. That's new. And the HF models, 20 meters CB and shortwave. So the VHF, UHF, there's two 7.5-inch models, the 2-meter 440, many of you are familiar with and have. The 2-meter 220 440 tri-band we'll discuss a little bit by request. Here's a new one, the 2-meter 440 plus. What's that all about? Well, that was developed because this was developed. The LMR, the Land Mobile Radio for government and commercial communication at 9 inches. Little different construct, not a lot. The basics are there, but the technical specifics are a little different. And the Scan 3 had already existed, and was getting such rave reviews. The question was, can you use that technology in a 2-meter 440 to take the great performance of the 2-meter 440 and give it just a little extra? And the answer was yes, and about 1.5 dB, and it's really substantial. So there's the 7.5-inch models, there's the 9-inch models. We're going to be discussing again the 2-meter 220 440, the 2-meter 440 plus, the LMR1, and the compact counterpoise collectively. You're all familiar with this. There's vehicle and home. This is really good for a niche market that's a growing niche. People want to be able to get in and out of parking garages, drive-throughs, overhangs, branches, things like that. And it's just great for that. For the home, HOAs, condos, apartments, homes that just don't want, an obtrusive antenna. This 9-inch, 2-meter 440 plus, that new model. Boy, you put that on the compact counterpoise in an attic, you'll be surprised, even amazed. And if you put it on in your backyard on one of these nice new extended masts that they make, or just on a mast on your chimney, you will be very surprised what you can get in a very stealth, inconspicuous antenna. 20-inch models for the backyard and stationary vehicle. And then the POTA, more and more popular, camp and field grounds. So here we are. These are the models we're discussing, like I mentioned, specifically for this presentation for NOARS, Northern Ohio Amateur Radio Society. Here it is on the back of a vehicle. That's the model QM22440. Most of you are now familiar that everything is different about this technology. Listen, most antennas, manufacturers want you to mount the antenna in the center of the roof, get all that metal all around. Well, there's only one center. I think this is actually an advantage. The plan is to use one of the upper corners of the vehicle, and there are 4 of them. So some also find success on hood mounts. I don't officially recommend it, but many are finding success with that as well, especially if it's not too close to the A-pillar. So that's different about this technology. And by the way, it's still omnidirectional because it's using essentially the downward metal of the vehicle as a counterpoise, kind of like a dipole kind of a configuration. The directionality you get when you mount antennas not in the center of the vehicle is primarily a problem with HF antennas, CB antennas, 10 meter, 20 meter, et cetera. Because essentially, if you mount it in the corner, the ground plane of the vehicle in one direction, essentially, if I can use the word, pulls the signal in that direction. Okay, so on the installs page of COMPACTenna, there are now pretty nice short YouTube videos. Reviews by others on the installation and the performance, showing the pretty plug and play when using a corner near corner or corner mount. So the first model is an update. Is the 2M22440, works on all 3 bands. A nice SWR in all 3 bands, put it near corner of the vehicle. And here it is on the new compact counterpoise, which I'll discuss in detail later, but that's the newness of the tri-band. These are the 3 new models to discuss. The 2M440 Plus, which I already discussed somewhat. All the high performance of the 7.5-inch, it's still a great antenna, really short. But this has an additional dB.5 of gain, and it's more than that. It's all that other stuff, all that other science and technology. It just does it even more better. If you can get 9 inches and still clear the your garage opening, or if you prefer it, it's a real winner, people. The LMR1. Land mobile radio, also 9 inches, similarly constructed, some additional stuff in there, amazingly covers all these very wide frequency bands. And the specifics of the SWR are on the specification sheet, which comes with the antenna as well as on the website. But this is the introduction to the land mobile radio community of COMPACTenna. It's just great for the Motorola, the Raytheon, the Harris radios, Apex radios, single band, multi-band. It just really fits a need there for a very small antenna that'll do all of that. Kind of unheard of. Well, it is unheard of until now. Motorola recently developed an antenna to do all of that and make it as short as possible, but it's still on the order of 2 feet long, something on that order. Very, very wide, bulky base with a whip and a spring. It works, but nothing like this. The compact counterpoise. What is this? it's a base station ground plane adapter kit. There have been ground plane adapter kits out there for VHF, UHF antennas for a long time. The problem is that when you look at VHF, UHF, 2 meter, 440, and then throw 220 in there, and, everything else in between, one ground plane adapter kit, another ground plane adapter kit, they're good at one frequency band, maybe very good at pattern. So you got SWR and you got pattern, and you got the different frequencies. So you got good here, very good there, very good there, but only good there, not so good there. Couldn't there be a ground plane radio kit that did everything and optimized both SWR and pattern for VHF, UHF, and everything else in between? Well, now you have it, and made in America, and very rugged, I might say. So you'll see that. There it is again. So here's the 2 meter 440 plus. I pretty much already explained the whole thing. Yeah. On my homepage, there's a really neat video showing full scale 2 meter signal at 25 miles. Why is that important? Because I discussed the reliable range, the non-line of sight. I discussed that. I discussed the diverse electromagnetic field Tesla-like coils, new science and technology, all of these kind of things. But what's really cool is when Brian Perry of Lake Cumberland Amateur Radio Association down in Kentucky did his testing on the video, and it's not a long video, he included the essentially non-line of sight test, where he went more than 25 miles away to his favorite site on top of a mountain just to see, how good is this 9-inch antenna. And, as usual, he compared it, with a short loaded whip, something on the order of about, I think, 12 inches, 15 inches, something like that, as well as high gain antennas, much longer antennas on the vehicle. And not only did this 9-inch 2M440 Plus do better. Now, by the way, the 2M440 7.5-inch did quite well, amazingly well for its size. So the expectation was greater with the 9-inch 2M440 Plus, but how much? Did it approach even closer to performance in line of sight, even line of sight? Non-line of sight, it's better, but line of sight at far ranges, hilltopping. Was it even closer to the performance of the standard technology, very long antennas? Oh yeah, it beat them. It actually didn't just get closer, it beat them. How is that possible? Well, we'll talk about that again sometime. But for now, it does it. And you have to see the video. It's a good invention. All right. Now we have finally the land mobile radio. Already discussed it. Does all those frequencies. What's it for? Digital and analog, of course. Police, fire, sheriff, emergency, state hybrid patrol, homeland security, United States federal, military, business. Oh, and this is important. Also GMRS and MERS. MERS at the VHF, GMRS at the UHF. It is absolutely also optimized for that. There in that frequency range there, the 462 to 467 for the GMRS, it is it's really, really good. Actually, Heartland Radio, Joe and Patty are listening. He's a systems integrator as well, as I think you all know by now. So he had a person come in with a GMRS setup, an Aries gentleman, amateur radio emergency service, and took the antenna that came with the Midland GMRS radio off and put this LMR1 on, and it was night and day, absolutely night and day. It was a lot of fun. So I mentioned this, all of these radios, it's a great application for that. Also excellent for base and repeater use, particularly with installations below 100 to 150 foot. Why? Because there you're getting more non-line of sight, right? So most of our installations are below 100 to 150 feet. So strongly consider the optimized compact counterpoise with any one of the VHF, UHF COMPACtennas, it's quite a performer. Summary. Okay. So that may leave you thinking, well, which antenna's for me? Well, it depends. You know, you in some ways, you know, ham radio operators are so diverse, but in one way they can be divided into a couple of categories. Some like to operate multiple frequency bands, jumping around all at the same time, different modes. They just love it and they're good at it. But there are some that are very focused. I tend to be more focused on maximizing, absolutely maximizing the performance on select bands. Okay, so really the COMPACtenna is models to fit a variety of those individuals. You take the 7.5-inch model. Well, you have your cost-conscious ham radio operator. Great performance, very small antenna, the lowest price. It's very competitive with even the Oriental antennas now for different reasons. And COMPACtenna has not increased prices during these unusual times. The 7.5-inch tri-band antenna, well, the same thing as this with an added magnetic field resonator. So great performance is added. The 9-inch model, again, now there, for your maximizing performance on select bands, that's for the ham radio operator who just wants the ultimate performance and where 9 inches is allowable. The LMR antenna, obviously, that's for that community, but it also includes the GMRS and MERS for that matter. And the Scan 3, clearly, a scanner antenna, great reviews on that. I think every single one, ehem.net, everywhere is 5 out of 5 on that antenna. Just wanted to quickly go over this. You're thinking, well, what antenna would fit your applications or your, suit your needs, your desires? You know, I mentioned the corner of the vehicle. Well, you saw magnet mounts, or you're familiar with them. Yes, but there are a variety of different kind of mounts. There's a through-hole mount. That's always good. You know, when you look at the magnet mounts, the flat style tend to provide the best SWRs. Well, not surprising. Along with the through-hole mounts and brackets with screw types like this, L bracket. It's closer to the vehicle. Well, so is the through-hole mount. The flat style magnet mount is. So, for example, Laird makes one that's quite flat. MFJ does too. There's a 3-inch and a 5-inch model available on that. But flat style tend to work better rather than the raised ones. And intuitively, it makes sense when you think back about the earlier slides. There are all kinds of really neat universal adjustable mounts that are made, very focused on the hatchback community of SUVs, crossovers, etc. They're great. So you put that near the corner, the rear corner of the vehicle, and then you have adjustable characteristics if you can't use just a real inexpensive standard, although these are not expensive, but real inexpensive standard L bracket. Here it is on the back of a cab of a pickup. All right. Oftentimes, here's a magnet mount on a pickup truck. Oftentimes it's nice to have a magnet mount, a good magnet mount around, because if you're going to do, let me go back to that. If you're going to do a permanent installation like this, even this, it's nice to start with the magnet mount in that area. Even if it's an aluminum roof, like some of the newer F-150s, it's still going to capacitively couple to the aluminum. You'll get a general idea of how it's going. And why is that important? Because sometimes there are other things going on vehicles. There are other antennas, or there's a roof rack mount, or there's a spoiler, or whatever the case may be. Sometimes the rear windshield wiper, you'll have more of an effect, essentially a parasitic effect in the near field on one side versus the other. So it's often good before you drill the hole to, if you're going to go that route, to have a magnet mount to get a general idea first. Okay. All right, there it is. All right. I'm not going to go over this math. I just want to say this is on the top, near the top of the installs page for the people that wanted to see the math. on magnet mounts. Do they work? Yeah, they work. They provide really good capacitive coupling, and of course, if you add a really thick rubber boot underneath it, you increase the spacing, you decrease the capacitive coupling, but essentially, with a 3-inch magnet mount, you're good on VHF and UHF. For HF, frequencies down to about 7 megahertz, 40 meters, a 5-inch one is good, but that doesn't mean it's recommended to use magnet mounts, especially if you're moving down the road. No. But for POTA, still operations and that kind of thing. Just to let you know, the math is there. So I've seen some math on various sites, but I wanted to put it all together for the ham radio operator that really wanted to see the mathematics of this, and include some of the additional discussions on fringing effect and that one, in case they were curious about that. All right, enough of that. Compact counterpoise, here's the key right here. It's like I said, with the counterpoises that are available out there, you've got SWR and you got pattern performance. They're both important. And on this design, you get a check mark on every one. Optimized check mark on every one. SWR and pattern performance on all those bands. The specific angle, the specific length, the specific diameter of the disc, all of it is important in developing that. So whether in an attic or in a outside in a chimney mount or backyard and an extended mast, it's really, really a good performer, especially, like I said, when you're non-line of sight, which the vast majority of our installations are to at least some degree. All right. Last thing, I wanted to add this, Elaine, because this is also new. I added it since last Monday because it's just really cool. It's not a new antenna, but it's another new video that was recently released. Doing 20 meters, thousands of miles, talking thousands of miles from just 20 inches above the ground. Isn't that just cool? I mean, isn't that just like kind of amazing? Because, even a wire dipole at 20 meters is about 30 feet long and typically suspended from a tower or from an extended mast or that kind of thing. There's a lot of real estate. Here we have a 20 meter antenna that's only 20 inches tall. It's 20 inches above the ground with a minimum ground plane counterpoise. Not really long wire radials. Going off in multiple directions. Oh, you only have 15 of them. Oh, you need 56 of them. No. And this link is also on my homepage, short video, but both Brian and his brother Chris, again, of Elcara in Kentucky, they showed this. They did another one with the antenna on the vehicle for such as POTA operation, and that was really good. But this shows that anywhere, at any time, your backyard, a POTA camping ground, emergency activation, whatever, small ground plane. And why? Because again, it's different. It's, when you're using those really long ground radials, you're essentially creating the tuning and the counterpoise with those radials. You need that. This is totally different. This is sheets of metal, again, sheets, but the sheets are creating an effective coupling, capacitive coupling to Earth, to planet Earth, the water table, etc. And this is an entirely different way of doing things. And therefore, not only do you have a small antenna, but important, you have a small antenna, fine, but what good is that if you have to have really long ground plane counterpoise? No, you have a small antenna with a small ground plane counterpoise. A combination of both, and that even works when you're up in the attic. If you use those formulas that I showed on the prior slide and plug in all of this math and get the surface area of this, you'll see that there's adequate capacitance coupling. Kind of cool. There it is, by the way. There's the 20-inch antenna for 20 meters. It's available in CB and shortwave too, but there it is. And there's the very small piece of metal, 3x3 sheath, 3x4, whatever. And this extension, 8-foot extension, you get really good SWRs on everything. 20 meters, 2 meter 440 here CB. It's very effective and very small ground plane counterbuoys. I mean, this is very inconspicuous. You can use a Magnum mount like the Hustler. It's a very good one. It's a 3H24 standard hamstick kind of thing. But the new thing was that video. It's very fun to watch. They were making contacts all around. Within an hour, they had their POTA activation. Within an hour, that was really nice. There it is up in an attic. Same thing, same kind of construct. Again, capacitive coupling to planet Earth, to the groundwater, the water table, etc. And here it is on a vehicle at a POTA activation. That summarizes the new. Oh, good. Just before 8 o'clock. Excellent. I think. I hope you found that interesting. It's all about developing things differently to help mankind in both fun but also urgent communications. The vision of the very small gives great appreciation in a glimpse of comprehension of the very large, all things. So I'll stop sharing. I do happen to have these models here that I can bring to the camera, but I'll turn it back to Carl to take the lead.
Hey, thank you, Dr. Jack. That was fantastic. Appreciate that. If you want to go ahead and do the demos or the show and tell, do that.
Absolutely. So I see myself in a very small screen at the upper left. Are you seeing this?
Yeah, I'm seeing you full scale here.
Okay, very good. So here's the 7.5 inch and here's the 9 inch. So there we go. You can see they're not much different, but there is the NMO connection with the phosphor bronze. Very reliable, very reliable. And as much as they've been made since the very beginning, you can see they're even more refined now in their appearance externally as well. And then this is the compact counterpoise. I'm going to see if I can see well enough there. Are you able to see that? There's the NMO base right there, the NMO mount,
Yes.
and the elements very rugged. So they're not flimsy whips. They're aluminum solid rods, a very sturdy construction. There's very little to assembling this. And we'll take one of the antennas, for example. Let's see if I can get it. Yeah, there it is. All right, we'll take the 2M440 Plus. I use it. It's just great. And there we go. You just screw that right on. And it comes with stainless steel, all stainless steel, including the screw hose clamps. And you just mount that on a mast and you are ready to go. So it's all right there. And just for informational purposes regarding that, thousands of miles from 20 inches above the ground, this is one in the package. And this is just cardboard for the shipping to protect the radome and whatnot. But there it is. That's all it is. I'm really open to questions, Carl.
Will that compact the radials, will that work with a 7.5 inch?
Absolutely, really well.
Okay, so I was thinking of getting a 9 for the car and then use my 7.5 home here base station. So, anybody else have any questions for Dr. Jack?
I got one. Dr. Jack.
Hi, Chris. Is that Chris?
That's Chris's hand. A couple of questions. And the 7.5 inch versus the 9 inch. Is the 9 inch going to come in a tri-band version?
No. No. The 9 inch is for the person that wants absolute maximum optimized performance at 2 meters. And oh, by the way, it's a real gangbuster at 442. But no, you would need an extra magnetic field resonator. And at this juncture, it's really important for me to focus on
2 and 440.
Well, yeah, with that antenna, but in general, as a business, keeping the models where they are and production, especially because, as you all may have noticed, this is a very strange world the last couple of years, and supplies are a challenge. I'm very nimble, so I'm okay, and I contract out to a number of fabricators, tool and die shops, whatnot. All right, but there's always a little engineering going on because I got to switch this or this a little bit, you know. So to meet the demand, it's important to keep the models. So sorry, no.
Okay.
The 2 meter tri-band is there. It's a great performer.
All right. The other question was the extension tinfoil. You use conductive tape. Could you use like refrigerator magnets and make a strip of them? Would that be easier and more cost effective? Because you can get refrigerator magnets at Dollar Tree.
You know, as long as you're getting a good conduction between the aluminum foil or whatever metal you would use, it's just aluminum foil is so inexpensive and available.
Right.
Yes, the answer is yes. Let me jump in and say, yes, Chris, it's a clever idea. Yeah, you put some magnet mounts on there. And what do I mean by connection? Well,
You need a conduction between the two.
yes. But at the end of the day, it's not even DC connection, is RF connection. But
Right.
but they're kind of one and the same when you simply get a proximity of the two.
Right.
Absolutely. Yeah, that'd be a great idea, right, Chris? In a POTA activation or whatever, just have a couple of magnet mounts. You don't even need the tape. You just unwrap your 8 foot of aluminum foil and stick those magnet mounts on and you're done.
Yeah, because you can get like 8 refrigerator magnets for $1 at Dollar Tree.
Oh, like that. Yeah. And the sheet of metal, you can get the 3x4 foot from the home improvement places, or you can get a couple of smaller 2x3 foot and overlap them and, make it. Actually, the video from El Cara talks about that a little bit. Talk about getting set up in like no time at all. It's like right there. And also, for your backyard, talk about discreet. What neighbor is going to complain about that? And that's
Exactly.
really cool because the second you get outside the house, by the way, typically your noise, your interference, your QRN drops dramatically when you, especially at HF, when you get outside. Now, I do HF from my attic, as you know, but the second you get outside your house, typically nowadays, especially now, years ago, much of the noise was mainly from the transformers up on the wires in the backyard or the front yard or what kind of thing, or, arcing going on, on the insulators. Nowadays, it's in your home. It's you. It's the switching power supplies on everything, so although that can be tackled, and that's a lot of discussion on my installs page on that. But the second you get outside, I mean, who's going to complain about a 20-inch antenna outside or that tiny little stealth VHF, UHF with counterpoise? You can't even see it. Go ahead, Chris.
Thank you. The other thing was, is there somewhere in the future an 80-meter version to be even taller?
Any version to what?
An 80-meter version.
Yeah, no, actually, I had to stop production on the Hammer 7, which was the 7-band antenna, 40 meter, 20 meter, 10 meter, 6 meter, 2 meter, 440, 220, all of that, because of not just cost in terms of money, but in business, cost is also complications, great antenna, and I still support it. But it just wasn't viable enough, especially when it took away from the other models. All right. And that 20-meter antenna that I showed, that's only $99. I mean, that's all it is.
Right.
Decisions are made in the world, in history, in an individual business, based on science, somewhat, a lot here, more than most, technology more than most, but often other things that come into play. If you've heard about the complications in getting raw materials, it's very real, people. It's very real. I'm okay, but I feel for companies that are, say, having, on the order of 100 to 1,000 employees, that kind of size, getting the materials. I know one gentleman who is a vice president of and I'll stop here, but of a manufacturing place of chemicals and whatnot, and he actually had to take his R&D engineers and not R&D further development, but use them in order to figure out how they can get other components, other chemical components to work, because some of the chemicals they just couldn't get. Isn't it amazing? All right, Carl?
I think Tom Porter had a question for you.
Yes, Dr. Jack.
Hi, Tom.
Hi there. Can you hear me okay?
Oh, I can hear you and see you. Great.
All right. Two questions. Number one, what is the material that you use to make the covering for the 7 and the 9-inch model? The black covering. Is it plastic?
Yeah, the quick answer is UV stable black ABS.
Okay.
That's actually commonly used, like your shark fin antennas on vehicles. It's the same material.
Okay. Is it the same material for both antennas?
Yes, it is. Now, in the past, I used a thin wall, not too thin, but thin wall PVC that was then painted with black UV stable paint. All right, but that has changed due to a lot of things in the world. But it's an improvement change. It's really shiny, really attractive. You can see it. It's really shiny.
Okay. Second question. About 2.5 years ago, I was in Florida. You were up here, and we were trying to get together, transmit. I was on, I forget, 20 meters or 40, whatever it was. And do you remember that? And what I was curious, was there any outgrowth from the antenna you were using up here to what you have today? Yes,
we were on 20 meters. And we were, of course, at a very low part in the 11-year cycle. And conditions, therefore, were very poor. If we did that again, not only would we have seen a blip on our screen, we would have made the communication. The answer to your question is yes. At that time, we were using 20 meters. It was the 20-meter component of the HAM-R7, the multiple band antenna. Well, that 20-meter component is right here in a $99 antenna now, but actually optimized, okay? Because it doesn't have the other bands that create the parasitic, et cetera, effect. So that's why that Alcara video is amazing. I mean, within 20 minutes, he was talking to Florida and Texas, and 20 minutes, everything's 20. No, within an hour, he was making, he totally succeeded in his activation with this antenna right here. So this is the optimized essence of what you and I were talking on at the bottom of the null cycle.
Okay, thank you, Dr. Jack.
Yeah, thank you. Good question.
Anybody else have questions for Dr. Jack? I guess not. Hey, Doc, thanks a lot. We really appreciate the time, and I will get this edited and try to get it up on YouTube. And thank you. Appreciate it.